Another example of solving an equation by using matrices is this problem here. Again, we want to go through the proper steps. The first step is that we want to find the determinant of this particular matrix here. So I'm going to pull that down. 5, -3, 4, -2. I want to find the determinant of this matrix, which is going to lead me to the inverse. So to find the determinant, 5 times -2 is -10 minus. -3 times 4 is a -12, and of course minus the negative is plus a positive. So my determinant is 2. This is my determinant. That leads me to looking for the inverse. To find the inverse, you say 1 over the determinant, 1 over 2 in this case, because there's my determinant here, 1 over 2, and we swap A and D, change B and C. Swap A and D, change B and C. So we come back here, we're going to swap these two here, -2 and 5, and we're going to change the signs of -3 and +4 to +3 and -4. And then we're going to multiply in, distribute in that scalar multiple of 1/2. So when we multiply here, we have -1/2 times -2 is -1, +1/2 times 3 is 3/2. 1/2 times -4 is -2. Half of 5 is 5/2. So here's my inverse right here. Right here. This is my inverse. Now remember that we talked about multiplying the inverse. When you multiply in the inverse, you multiply in on the left. And what you do to one side, you have to do to the other. If you don't write in the step of writing in the inverse right here on this side, it's not going to matter. Remember that this inverse times this matrix is really going to kind of cancel each other or give you the identity matrix of 1, multiplying by 1. I'm going to write it, but it's not necessary that you do. But this is -1, 3/2, -2, 5/2, and then that's going to be multiplied times 5, -3, 4, -2, times x. And remember that this part is really not necessary to write unless you just need to, because it's just going to cancel each other, or actually be the reciprocals, quote unquote, of each other and go to 1. So then I have, don't forget, the inverse is going to be on the left, -1, 3/2, -2, 5/2, and then times this 2 by 1 matrix, 5, 10. So again, as we said, these two matrices are going to go the identity matrix. They're somewhat going to cancel each other or go to 1. They're similar to reciprocals, and you're going to have x equals. Then you're going to go back, do what you've done before, multiply row by column, row by column. So here's my 2 rows, and then here's my 1 column, and I'm not going to circle it. So when I go back to multiplying, I have x equals -1 times 5. I'm going to set this up. I'm going to go back real quickly, and I'm looking right here. This is a 2 by 2 matrix. This is a 2 by 1 matrix. Of course, I look at those inner dimensions, and I can see that that's going to be multiplied, because the 2's are the same. But my outcome is going to be a 2 by 1 matrix, 2 rows by 1 column. And so here's what I'm going to have. I'm going to have 2 rows, and then I'm going to have that 1 column right there. So I have -1 times 5 is -5. Then I have 3/2 times 10. You can calculate that, or you can figure 2 will go into 10, 5. 5 times 3 is 15. And -5 plus 15 is 10. The second row, -2 times 5 is -10. 5/2 times 10 is 25. 2 will go into 10. 5 times 5 times 5 is 25. When you add those together, you get 15. So when you actually write that final matrix, it'll look 10, 15. And that would be your answer. Again, to go back and just kind of remind you how to check it. I go back and I look at my problem up here, and I say, okay, I'm just going to substitute in. I have 5, -3, 4, -2, times the answer that I'm thinking it is, 10, 15. And I would do the row by column multiplication, and it should check out to give me 510. So of course, if you have time on a test, you want to go back and always check it. So again, this is solving an equation using inverses. The answer here to x is the 2 by 1 matrix 10, 15.